Hello everyone. We are going to solve a very famous problem from GFG, that is coin change problem. In this problem we are given an array of coins and where each element represents a coin of a different denomination, and we are also given a target value, that is sum, and we have unlimited supply for each coin type. So which means that we can use any number of coins and our task is to determine the minimum number of coins which is needed to obtain the target sum. And let's suppose if it is not possible to form the sum, we can simply return -1. So in this particular problem, the parameters that are changing is one will be the index to traverse the entire array, and another thing will be needed is the sum. So there are two parameters that are changing, so we will be using 2d dp. So let's write this code. First of all, let's calculate the size of the array. Points dot size. After that I will create my 2d vector dp. Of the size would be n and column would be sum plus 1, because the value will be from 0 to sum, so these are sum plus 1 values, so that's why, and I will initialize all values with -1. After that I will write the function. One will be index, then another one will be sum, then my array coins and my dp array. So let's think about the base condition. Base condition could be I will start my function from n-1 value, from the index n-1. So the base case can be if my entire array is traversed, so my the value of the index, if it is less than 0, then I will return from there, or there can be one more case. If my sum becomes less than 0, then also I will return. So in this case I will return a large value, because we need to return because in the particular problem we need to return the minimum value. So let's suppose if I use a very large value, so it will not be considered, so that's why I am returning a very large value. And if my sum is equal to 0, then I will simply return from my function. And another condition for memoization, if my value is previously been calculated, if it is not -1, which means that it is already calculated, so I will directly use this particular value. Fine. Now there can be two possible cases. If I take that particular coin, or either I will not take that particular coin. So first of all, if I exclude the particular coin, so I will simply uh, go for the next index. Sum will remain as it is, coins and dp. Now another possible case could be if I include that coin. So if I include that coin, my count will be increased by 1, so 1 plus the function. Now we can use a particular coin any number of time, so we will again go to that. uh, we will not change our index, and sum will be minus a not arr but coins of I, because we have already taken that coin, so sum will be reduced. Now coins and TP, fine. And now I will store the value I as sum and return the minimum of include and exclude. Okay, fine. So this is a function, and I will call the function and store the value in ans variable. Sol n minus 1 comma sum, then coins and TP. And there is also last line given, if it is not possible to form the sum, we need to return minus 1. So we can identify if it is not possible when we have when we are getting this large value 1e6. So if my ans is equals to 1e6, then I will return minus 1, because it is not possible to get the sum from the given coins. And if it is not, then I will return my ans. So let's try our code. It is giving the correct output. Let's try to submit this. So yes, it is accepted.